Hi children, in this video we are going to discuss about that the worksheet problems from the concept elementary geometry. Already we discussed about that what are the synopsis from that elementary geometry we learned, right? So in this video we are going to discuss about that worksheet problems. Okay, worksheet 1 first problem is, so see here matching. So what is that? Here we have that two groups, the group A and group B. Okay, so here what is the first question? That is space. So in generally space means what? In a space we can draw that lines, planes, so many we can draw that, right? So as per that given answers, I mean given options, what they given in that group B. Okay, according to this one, here space means we can take that one as lines, planes. Okay, we can draw that lines and planes also in that space. Yes. So here next thing is plane. So what about that plane? Already we discussed, no, it's a flat surface, okay, which can be extended endlessly in any direction. Okay, that is called plane. Okay, so what is here plane? Plane means that is a flat surface. Okay, next intersecting lines. So intersecting lines means already we know that, right? Intersecting lines means two lines passes through the same point. Two lines passes through the same point. We will call that lines are intersecting lines. Okay, so we are having here how many points they are asking. According to that group B options, here these two completed, we have that only two. So same line is there. So we are saying that intersecting lines means two lines must be required. So first option is not correct. Okay, come to that second one. Through one point, yes, obviously two lines passes through the same point. Same point means here we are taking a single point. That one already we know that, right? That is an intersecting point. So how many points are there? 1 point. So intersecting lines, that is 1 point. And here collinear points. Collinear points means what we discussed. Here 3 points, 3 or more points lies on the same line. Yes or no? Here this is one of the line. On the same line here I am taking the 3 points A, B, C. Okay, already we know that, right? 3 points or 3 or more points lies on that same line. Then we will call that points are collinear points. Which one they given? Same line. Yes, obviously here they not given about that points. Just on the same line. Okay, we are having 3 or more points. So collinear points, that is the same line. Okay, so here which option is correct? Space, that is the flat surface. So A is B. So space is equals to what is that here? Lines and planes. So A3. Here we have that. Next, plane is a flat surface. So B is 4. And here intersecting lines. Intersecting lines we taken that one as 1 point. So C2. And here D, that is 1. So that is collinear points, same line. So which option is correct? Option 3 is correct here. Okay. So let us see that here second question, what is that? Given two distinct points, there are so many lines passes through them. Okay. Here actually what is the statement they given? Given two distinct points, which means 2 points I am taking on that plane. Okay. Here these two are two distinct points. By joining those 2 points, according to that given statement, what they are saying here? There are so many lines passes through them. Is it true or false? Obviously that is false. Why? Because by joining 2 points, we can draw that only one line segment. By joining 2 points, we will draw that only one line segment. That's why here this is a false statement. So children, see here next question. If M represents the number of lines joining 2 points at a time, okay, then the formula for finding, here this is not X, okay, for formula for finding number of line segments. Formula to find number of line segments. So here we can take that one as some n. So n is equals to number of points we can consider. Why? Because according to that options, when you are observing these all options, we are having answers in terms of n. That's why here I taken n. That n means here number of points. Okay, so here what is that? For example, I taken here 2 points, 2 distinct points, and one more thing here we have to consider, that is if the points should be non-collinear, points should be non-collinear, then what is the formula they are asking here? Okay, so two non-collinear points, while you are joining 2 points, here we are having how many line segments? One line segment. And here I am going to take that 3 distinct points, then how many line segments I will get from here? 1, 2, 3. And again I am saying here, the most important point what we have to keep in your brain, that is those 3 points should be non-collinear. If 3 should be collinear means then we will get that 3 collinear points there, then we are having only one line segment. So when we will apply this formula means if the 3 points should be non-collinear points. Is it clear? So what is that formula here? That is n into n minus 1 by 2. Okay, so here just take that one of that example. Here n is equals to, I am going to take that 3 distinct points. How many distinct points? Yes, 3 distinct points I am going to take here. Just I am substituting that 3 here. So 3 into 3 minus 1 by 2. Is it clear? So which is equals to 3 into 3 minus 1 is, that is 2 whole by 2. So 2 and 2 gets cancelled, we will get that 3 line segments. Just observe the figure here. I am taking here just only 3 points. By joining those all points, here we got that a triangle. So 1, 2, 3. By joining 3 non-collinear points, here I am getting 3 line segments. So here I am getting answer is 3. So let us take one more example. Yes. For example, here n is equals to some 5. So here let us take that any 5 dots, any 5 points. Okay, by using 5 points, how many line segments we have from this figure? That is that figure is having that distinct points only, no. So just substitute that 5 into 5 minus 1 whole by 2. So 5 into 5 minus 1 is 4 whole by 2. So 2 to 4, which is equals to 10. 5 to 10 line segments. Maybe you have a doubt here, what is that? Madam, I have here only 5 line segments. Why you are saying here 10 line segments? Why? Because here A, B, C, D, E. So we have here 5 points. Okay, I accepted. What about that? For example, here those two also line segments only, no? 2 distinct points. Whenever you join the 2 distinct points, we will get that one of the line segment. Just which formula I am using here? That is to find for a total number of line segments. Either those are diagonals or whatever it may be. Okay, here A and D is there. If you join A and D, we are getting one more line segment. Yes or no? So that's why here like this, how many line segments totally there means? Actually previous we have that only 5 line segment. Just count that AD is one of the line segment, AC is another line segment, EC is another line segment, next BD is another line segment, BE is one more. So 1, 2, 3, 4, 5. 5 diagonals and 1, 2, 3, 4, 5. 5 sides. So totally how many line segments are there? 10 line segments are there. So here we got that total number of line segments is equals to 10. So by using this formula, we can find that for any figure which is having distinct points, must be, you have to say that distinct points. Then only we can apply that formula, that is n into n minus 1 by 2. Okay. So children, see here next 4th question. If x represents a number of lines, x represents a number of lines through a given point P. Through a given point P. So take that the point, that is P. Through that point, x represents a number of lines through a given point in a plane, then the value of m is, so here just then the value of m means how many lines we can draw that, we can, how many lines passes through that same point, or the how many lines we can draw through that same point. That is the question. Okay, see here I taken only one point. So just say that this is one of the line. Here they are not asking that line segments, that is a line. Okay, there is a difference between that line segment and line, right? Already we discussed that. So line segment means it should have that 2 points. Okay, then only we can join those two, then only we will get that line segment. But here only one point is there. But what is the question? Just listen carefully. That is, the X represents number of lines passing through the point they are asking. Number of lines passing through the point. So that is a line, not a line segment. So through that point, how many lines we can draw? So like this way we can draw that infinite number of lines. Yes or no? Yes, obviously, exactly these number of lines. We can't say that. Okay, here one more line I will draw. In between these two, one more line I draw. Okay, that's why here through that one point we can draw that infinite number of lines, not line segments, infinite number of lines we can draw here. Okay, so next fifth question is, the simplest of all geometrical figures which has no size but has a position. Okay, which has no size but it has a position. So what is that meaning? In that simplest form of all that geometrical figures, just I taken here one of that plane. Okay, here if you take that plane, then this is having that any thickness or anything is there here? Actually plane is a flat surface. So on that plane I am going to take that one of the point. Then according to that question here, the simplest of all geometrical figures, whatever it may be from that all, which has no size. Here I kept that one of the point. Is that point is having that any size? We can't say that. Here this is one of the size and this is one more size. So exact something I kept here. So no size but has a position. But we can say that here one of that point is there. So here that is a point. So come to the next sixth question. Three or more points in a plane are said to be collinear if they lie on the, okay, in that previous question we discussed that, right? When we can say that given points are collinear or given lines are collinear, already we discussed in the theory part, right? But here they asked about that three or more points in a plane, when we will call those are collinear. When we can say that all are lies on that same line. Three or more points lies on that same line, then we will call that points are collinear points. Okay, so answer is same line. So here question number 7, what is that? In the given figure, point P is called. Okay, just observe the figure here. Here point P is called. What we will call that point? Here one of the point is there, no? So what we will call that point? So before going to that, here we have to observe that in that figure we have that how many lines? Okay, if two lines are passing through the same point, then we will call that one as intersecting lines, or that point is intersecting point. More than two lines means three or more lines passing through the same point, then we will call that lines are concurrent lines. What are those? Concurrent lines. So here that point is known as a point of concurrence. That is a point of concurrence. Another name is also there. What is that? That is a concurrent point. So just observe here, that is a point of concurrence, or another one is a concurrent point. Okay. Next question is, in the eighth question, in the given figure P, O and Q are. O and Q are. Just observe that figure where we have that O. Here we have that O, some point. Okay. Next Q. Here we have that Q. Those two are which type of points? Those two lies on the same line? No. So those two should not be collinear. Okay. So after that non-collinear. If the given points are not collinear, then the given points are non-collinear. So come to the third option, that is a point. Already we know that given O and Q are points. Yes. But here O and Q are points, as well as those two are non-collinear points. Okay, according to this question, actually O and Q are, according to that options also we can say that collinear, non-collinear points. Yes, here this one also correct, as well as if those two also points also know here. So we can say that O and Q are points. Those two are which type of points they will ask, means non-collinear points. Is it clear? Next here, which one of the following is a simple closed curve? Okay, simple closed curve means here starting point and ending point of a figure both also same, right? Then only we can say that the given figures are simple closed figures. Already we discussed that. Simple closed figures and closed figures. There is a difference between those two, right? In a closed figures means then we have that some other 2 points also there. Okay, ending point, not only starting point and ending point, that is having some other intersecting point also there. Then also we will call that one as a closed figure. Okay, come to that simple closed figure means here the starting point and ending point of a figure must be or should be same. Okay, so here which is having that same points like that, just observe that this is that open figure. Okay, why? Because this is a starting point and ending point, those two are different, so that is not a closed figure. Fine. Next, come to that second one. Here, for example, if you start from here, then I drawn like this. Again, this is the ending point. So starting point and ending point of a figure both also same. Okay, so we can say that this is that simple closed figure. Okay, if you have doubt means just go for that remaining options also. Okay, so come to that here. Here this is the starting point and this is the ending point, two different points. So that is open figure. And come to that, here you may have doubt. Here madam, this is also a closed figure. No, then why you are saying this is only the simple closed figure? Here in that question they ask that simple closed figure, not a closed figure. Okay, so here this is a closed figure, but this is having two other points also. Okay, that's why we are saying this is not a simple closed figure, but that is a closed figure. Okay, next come to that one. Here this is the starting point and this is that ending point. So two different points are there. That's why we will call this one as open figure. So which option is correct here? That is option 2. Okay.